Example 11, a pipe has an inside diameter of 8 inches. How much larger is the cross-sectional area with a 1/2 inch thick wall than a 3/8 inch wall? So we have two different pipes, two different size walls. It's kind of like the same as the washer problem we just did a moment ago. The thickness of the wall is this bit, and we need an inner radius for these in order to do this. So we have two different pipes, and we're looking at cross sections of pipes. So we start with a dot to represent the pipe, and we're going to have a thicker wall and a thinner wall pipe. Let's see here, and let's make the pipe. Let's make it a purple pipe. That'll be fun. So we're going to have a purple pipe. That and clone it. And one's going to have a 1/2 inch wall and the other's going to have a 3/8 inch wall. So let's make that the 1/2 inch wall. 3/8 is less than 1/2, right? We'll make that a little bit thinner. There we go. Find my center. All right, so if it has an inside diameter of 8 inches, all right, inside diameter is 8 inches, both cases, so we have one thicker than there. So if the diameter is 8 inches, what's the radius? 4 inches, right? So the inner diameter of both of these is 4 inches, so that's 4 inches, and this is also 4 inches. Then I'm looking at this other diameter, the other radius I'm looking at. Let's make it green. They're telling me the thickness of the pipe is 3/8 of an inch and the thickness of the pipe is 1/2 an inch, or vice versa, 1/2, 3/8, right? Well, once again, we're looking at the the outer radius, right? The outer radius is green, so I'm going to say R sub O, right? This bit right here is 4 inches, right? And this little bit here is 1/2 inch. So notice this time the inside radius plus the thickness equals the outside radius. So this time they're telling us inside, not outside. And the same deal over here. The inside radius here is 4 inches. This little bit here is 3/8 of an inch. All right? So if I look at the first pipe, let's call this pipe 1, we'll call this pipe 2. It says, how much larger is the cross-sectional area? So they're looking for how much larger. We're going to subtract the two areas. We're going to find both areas and subtract big minus small. So if we look at pipe 1, the area of the outside, the area of the big, right, is going to be pi times its radius squared. What's radius is simply 4 plus 1/2, right? 4.5 or 4.5, take your pick, we'll go 4.5 squared. The area of the small one is going to be pi times the inner radius squared, which is going to be 4 squared, right? Our calculator can evaluate those four, so we can do pi times 4.5 squared and pi times 4 squared. That gets me 63.61725 and 50.26548. And just like the other problems, the cross-sectional area, that purple strip there, is simply the outer area minus the inner area. So 63.61725 minus 50.26548 gets me, the total area of pipe 1 is going to be 13.35 square inches. If we move on to pipe 2, the bigger area, this radius is 4 plus 3/8. If you guys memorized your eighths like you're supposed to a few chapters ago, but 3/8 is 0.375. So 4 and 3/8 is 4.375 squared. And then the area of these smaller circles is going to be pi times 4 squared. This still equals 50.26548. That didn't change. But the outer area is going to be different, right? So if I do pi times 4.375 squared, that comes out to 60.13205. So the area of pipe 2, the cross-sectional area, the purple strip on pipe 2 is going to be 60.13205 minus 50.26548, which is 9.86 or 9.87 if I round to 2 decimal places. It didn't specify anything about significant digits here or number of decimal places. I'm just going to a couple decimal places. So when it says how much larger is the first pipe than the second pipe, we just take the larger area minus the smaller area to figure the difference. So the difference in area
3.57.
3.57 square inches. Obviously, lots of calculations going on here. Use a calculator to calculate. You do the problem properly, but use the calculator to do the calculations for you. I don't want you getting more problems wrong because you're calculating wrong. Okay, I want you to know the formulas, understand the formulas, how to build the problems, but let the calculator do the calculations for you.